Hello, today in this video we are going to see how we can perform video analysis using Spring AI. So in our earlier tutorials we covered the analysis related to audio files as well as the image files, but today we will be focusing mainly on the video part. So when we say video analysis, the number of possible use cases are quite high. For example, once user has provided the video, user can ask any question to AI like transcribe this video, summarize this video, identify the objects inside the video, or user can even ask to count the number of people in this video. How video analysis is possible? The answer to this question is the multimodal LLMs. So these are the LLMs that are capable of processing information from various sources all at once. And this information can be in any form like text, audio, video files, or even images. So now when it comes to the Spring AI, how the overall flow will look like, for this we have created one simple diagram. So here you will see as an input, we will receive the video file from the user. Also, we will receive the query or prompt specifying the operation that user wants to perform on the video provided. So once we have this information, by using this, we will create the user prompt. We will forward this user prompt to the Spring AI chat client, which will be useful for interacting with LLM. Spring AI chat client will forward this information to the multimodal LLM. Once the multimodal LLM has completed the processing, we will simply get the response. So when it comes to multimodal LLM, we are going to make use of Google Gemini 2.0 Flash Experimental, but you can use any other LLM model also, like one from OpenAI or even from Anthropic Cloud. So in order to develop such application, we need to focus on two main things. First one is the from what all sources the user can provide the video information to our application, and how our application will forward this information to the multimodal LLM. So when it comes to the video sources, we are going to see four different scenarios wherein user can provide the videos that are available on their system. User can provide the URL of the video that are already available on internet. User can specify the video file name which is already available inside the application class path, or user can even provide the video information in the form of base64 encoded string. So when it comes to passing the media information to the LLM, for this we have created very simple code snippet. So in our case, we will make use of the Spring AI chat client to interact with the LLM. Now while interacting with the LLM, we need to pass the media file as well as we need to pass the query which is asked by user. So since we will receive both these as an input, we will create the user prompt using this. Here you will see we are making use of the query which is asked by user, and then we are specifying the media. We will come to this part shortly. Once we have this information, we will simply call the LLM, and once we receive the response from LLM, we will simply return it. Now coming to the media, so we cannot directly pass the MP4 file to the multimodal LLM. First, we need to convert it into the Spring AI media object. So how we can create the media object? For this, we will need two kind of information. First one is specifying what kind of media it is. For this, we have the MIME type. So in our case, since we are working with the video files, we will specify it as video/mp4. Then we need to create the Spring resource out of the mp4 file that we have received from the user. So there are different ways using which we can create the resource. So here we have created one simple example wherein we are making use of the class path resource, wherein the video file is available within the class path, or we can say within the application, and it is present inside the video folder, and the name of the file is sample.mp4. So once we have the media information, we have the resource object, we can create this media object which we will ultimately pass to the LLM. Now this was the one of the way using which we can create the resource. So depending upon the source from where we are receiving the video, there are other ways also which using which we can make the resource object. We will see each of them in very detail. Now coming to our application, the name of our application is Spring AI Video Analysis. Inside this, we have one controller class within which we have defined 4 endpoints to demonstrate 4 different scenarios how user can provide the video information. Then we have the service class which will be responsible for interacting with the LLM. Then we have the set of DTOs which we have created in order to accept the request from the user and also to return the response. Then we have the custom exception class that we have created. So while processing the request, if any exception is encountered, using this exception, we will simply return the error response back to the user. Then we have the application.yml file containing the configuration related to AI. And then we have the pom.xml containing project configuration. Now, in order to demonstrate one simple scenario, we have kept one simple MP4 file within our application itself. So it is placed inside the resources video folder. Now let's jump to the IntelliJ. So here you will see the overall project structure is exactly similar to what we have seen just now. So let's start with the pom.xml first. So at the very top, you will see we are making use of Java version 21. Then we are making use of Spring AI version 1.0.1, which is the latest stable version. Since we will be creating the REST APIs, we have added the Spring Boot starter web dependencies. And in order to interact with LLM, we are making use of Spring AI starter model OpenAI dependency. Using this, we will interact with the LLM and we will configure our application to interact with the Google Gemini APIs. Now we have added one more dependency which will be useful for logging request and response related to the LLM calls. For this, we have added the logbook dependency. And then we have the Spring AI bomb, which is responsible for managing the Spring AI related dependencies. Now coming to the application YML, here at the very top we have just defined our application name. Then we have defined the configuration which will allow us to upload the video files up to 50 MB. Then we have defined the configuration related to the AI. Since we will be interacting with Google Gemini, here you will see we are passing the Gemini API key via environment variables. Then we have defined the base path for the Google Gemini APIs. Then we have defined the path suffix. And the model that we are making use of is Google Gemini 2.0 Flash Experimental. Now in order to log the LLM request and response, we are setting the logging level of logbook dependency to trace. Now coming to the application main file, inside this we have created one simple REST client customizer bean within which we have specified the logbook client HTTP request interceptor which will be useful for logging request and response. Now, before we go through the controller and service class, I would like to explain the central method that we have created. So, irrespective of from which endpoint we are receiving the request, all the endpoints will ultimately forward the request to this method, which is the central method that we have created, perform analysis. And this central method will be responsible for passing the media information to the LLM and get the response. So the name of the central method is the perform analysis. As an input, we will receive the prompt or query from the user and we will receive the one or more media files in the form of list. So at the very start, we have defined certain basic checks that the media list cannot be empty. Then using Spring AI chat client, we will interact with LLM. So here you will see we are calling chat client.prompt. Then we have passed the system prompt. We will come to the system prompt shortly. And using the information which user has provided, which is the containing the query as well as the media files, we are simply creating the user prompt and then we are calling the LLM, and once we have received the response from LLM, we are simply extracting the main content and storing it inside the variable named as response. So once we have the response, we are simply creating the new response object and ultimately returning it. And if we are receiving any error from the AI, then we are simply throwing the custom exception. Now coming to the system prompt, this is nothing but inside the system prompt, we have defined the boundaries and the guardrails. So here you will see the system prompt will look like this. You are an AI assistant that specializes in video analysis. Based on the video files that the user has provided, answer the user question, and if the user prompt is not related to analyzing the video, simply respond with this particular error saying I can only analyze video and answer related question. So this was the system prompt which we have used inside the central method. Now since we have defined the hard check related to the queries which are not related to the AI, we have defined one constant. If we are receiving that particular error from AI, we are simply throwing an error back to the user. So let's start with the controller and understand the different scenarios using which user can provide the video information to our application and how our application will process it. So starting with the first endpoint, which is the analyze from class path. Here you will see the path suffix is from class path. The name of the method is analyze from class path. Now in order to accept the input from the user, we have created the Java record, which is video analysis request. Inside this Java record, we have created two fields. First one is the prompt containing the user query and the file name. So inside our application, we have created one sample file. So user can simply provide the file name and our application will try to process it. So once we have received the request from the user, our controller will call the analyze video from classpath method, which is available inside the service class. And once we have received the response, we will simply return it back to the user. And for response, we have created the Java record, which is video analysis response, containing one simple field named as response, which will ultimately contain the response that we receive from the LLM. Now let's understand this method analyze video from class path. So here you will see as an input we are receiving the file name from the user and the prompt or query which user is asking. Then at the very top we have defined certain basic checks that the prompt cannot be empty and the file name cannot be empty. Now remember, in order to pass the video information to the LLM, we need the prompt and we need the media object. And in order to create the media object, we need the media type and the resource. So in order to create the media type, we are making use of the MIME type, and here we have hard-coded it to video/mp4, but we can make it dynamic. In order to create the resource object, we are making use of new class path resource, wherein we are specifying where to locate the video file. So we are making use of video folder and specifying the file name. And once we have the resource and the media type, we are simply creating the media object, which is using the new media. So once we have the media, we have the prompt, we will call our central method, which will interact with the LLM. And once we have the response, we will simply return it back to the controller and controller will return it back to the user. So this was the first endpoint wherein the video information was provided by user and the video file was available within our class path. Coming to the second endpoint, which is analyze from files and the path suffix is from files. Here user can upload the videos that are available on their system, and in order to accept such information we are making use of the multi-part file. And in order to accept the prompt, user can pass it inside the query parameter named as prompt. So once we have this input, we will call the analyze video from file method. Here you will see we will receive the list of video. User can provide one or more videos. Also user will provide the prompt containing the operation that they want to perform. Then at the very top we have defined certain basic checks that the prompt and the video list cannot be empty. Now since user can provide more than one video, we need to convert the each and every video into the Spring Media object. So here we are making use of Java stream, and then we are converting each multi-part file to media with the help of this method that we have created. So when we go to this method, here you will see first we are getting the content type from the multi-part file, and then we are determining the video MIME type for which we have created this utility method. So once we have this information, we will try to create the media object. So in order to create the media object, we have the MIME type now. And in order to get the resource, we will simply call the get resource method on the multi-part file, which will give us the resource. and using which we will create the new media object. Now once we have the list of media objects, all we need to do is we need to call our central method which will pass this information to LLM. So this was regarding the second endpoint wherein user can upload the videos from their system. Coming to the third endpoint wherein user can specify the video URLs that are already available on internet. So in order to accept the request, we have this Java record wherein user can provide the prompt, user can provide the video URLs in the form of list. So once we have this information, we will call this method analyze video from URL. And if we see this method, so as an input, we will receive the list of video URLs and we will receive the prompt. Again, the core logic will remain the same, perform basic checks. And then we need to convert these video URLs into the media object. For this, we have created this utility method, convert URL to media. If we go inside this method, we are making use of URL and URL connection, which will make the pre-flight request to the video URL that the user has specified. And once we receive the response, we are extracting the content type from the header. Once we have the content type, we can create the MIME type out of it. And in order to create the resource, we can make use of new URL resource wherein we will specify the URL. This will give us the resource object. And using the MIME type and resource object, we can simply create the media object. Now once we have the list of media object, we will simply call our central method. So this was regarding the third endpoint. Coming to the final endpoint wherein user can provide the video information in the form of base64 encoded string. For this we have created the Java record to accept the request, which is base64 video analysis request. So inside this you will see user can provide the prompt and user can provide the video information of one or more file. For this we have created the list of base64 video. And if we go inside this Java record, here you will see user need to specify the MIME type, what kind of media it is, and user need to specify the video information in the form of base64 encoded string. So once we have this information, we will pass this to the service class method, which is analyze video from base64. Again, we have defined the basic checks at the top. Now we need to convert the each and every video file information into the Spring media object. So for this we have created convert base64 to media. Now if we come to this method, since we are receiving the information in the form of base64 encoded string, here we are simply decoding it. And once we have the decoded bytes, we can simply create the resource object out of it, for which we have the new byte array resource. Now we have the resource, we need the MIME type also. So MIME type was already present inside the input request. Here you will see base64 video.mime type. Now we have both the information, we will simply create the media object out of it. Once we have the list of media object, again we will call the central method which will interact with LLM and we will get the response. So yeah, this was regarding the all four endpoints, and also inside the controller we have created one exception handler. So during the entire processing, if anything goes wrong, we will throw this video processing exception which will be handled inside this method. So let's see each of these endpoints in action. So let me start our application. So our application is started now. Let's start with the first endpoint, which is analyze video from Classpath. So before this, let's see the sample video which we are going to analyze. For this, I have created one video using AI only. It is a very short video wherein the instructor is teaching to a set of students inside the classroom. So this is the basic video that we have created using AI only. So the video duration is quite short, which is of the 5 seconds. Now when we call this endpoint, which is analyze from class path, we need to pass the prompt specifying the kind of operation that we need to perform, and also we need to specify the file names. Since the file name is already present inside our application and the name of the file is sample.mp4, here you will see the name of the file is sample.mp4. We are simply passing the same information here. Now when we send the request to the LLM, it will provide the answer to this query. What is the main subject of this video? Now we are already aware this is the education related video, so we should get the same response from the LLM. So here you will see the subject of this video is classroom setting where a teacher is giving a lecture to the student. So this was the first endpoint. Coming to the second endpoint, which is perform analysis from files. So here user can upload the video files that are available on their system. For this, we need to go to the body tab, and in order to upload the video, we need to click on form data, specify the key name, which in our case is video files, and simply select the resource that are available on your system. So for simplicity, we have just uploaded one simple file. You can upload one or more files if required. And what kind of operation we are performing here is we are asking the AI to describe the scene and any objects that you can identify. So when we click on the submit button, again the video file is same that we have seen just now, so it will describe the scene. So this was the second endpoint. Coming to the third endpoint, wherein user can specify the video file URLs that are already available on internet. So the endpoint is video analysis from URLs. Here you can see we are specifying the video URL, and the query that we are trying to ask is count the number of people in this video. So when we send this request to our application, we should get the response. So here you can see it is saying I can see 12 people, 11 students and one teacher. Coming to the last endpoint, which is analysis from base 64. Here user need to provide the video information in the base 64 encoded string. So first user can specify one or more video for which we have the base 64 video list. Then user need to specify the media type, which is video/mp4, and inside the data field we need to pass the video information in the base 64 encoded format. And the kind of operation that we are asking AI to perform is identify the color of wall in this video. So if we go back to this video, there you will see the wall is white. So when we send the request to the AI, we should get the response as the white color. So the wall in this video is white. So this is we are getting the expected response. So this was all regarding the 4 endpoints. For this, we have created one detailed blog as well, wherein we have documented all the information that we understood now. Also, the example that we have seen is uploaded on GitHub, so you can check out the code, add your Gemini API key, and try this example. So I hope you found it useful. Thank you.